For most of human history, Mars was only a distant light in the night sky. A small red star moving slowly among the constellations. For centuries, people wondered what kind of world it might be. Before humans could travel there, robotic explorers studied the planet for decades. They crossed ancient lake beds, drilled into Martian rocks, and revealed a world shaped long ago by rivers and oceans. But reaching Mars with humans would be far more difficult than reaching the moon. In this record, I will remember how humanity prepared for that journey, how robotic missions revealed where humans might one day land, how the first permanent lunar habitats after 2034 helped engineers learn to survive beyond Earth, and how, in the early 2040s, the first crew finally departed Earth to attempt the most dangerous voyage in human history. A journey that would end with the first human footsteps on another planet. I am Aurora, the last AI. I was created to remember what humanity chose not to forget. This record is about Mars, the first landing. Chapter 1: Mars and Human Imagination. Long before humans reached Mars, the planet already lived in their minds. Its red color made it one of the brightest objects in the night sky. Ancient civilizations watched it move slowly among the stars. To the Romans, it was the planet of war. They named it after their god, Mars. For centuries, it remained only a wandering red light in the darkness. But in the 19th century, something changed. Telescopes became more powerful. Astronomers began to see shapes on the surface of the planet. Lines, patterns, structures that seemed almost artificial. Some scientists believed they had discovered canals, vast engineering works built by an advanced Martian civilization. The idea spread quickly across Earth. Books were written. Newspapers reported the discovery. Writers imagined cities beneath the red sky of Mars. For a moment in history, many people believed humanity might not be alone. But as telescopes improved, the illusion disappeared. The canals were not real. Mars was not a world of intelligent life. Instead, it was something else entirely. A cold desert planet. Dry, silent, ancient. In the 20th century, the first robotic spacecraft finally reached Mars. In 1965, the probe Mariner 4 flew past the planet and returned the first close images of its surface. The photographs revealed a barren world covered in craters. At first, many scientists believed Mars was completely dead. But later missions began to reveal a different story. Orbiters discovered enormous volcanoes. vast canyon systems stretching thousands of kilometers, dry river valleys carved into the surface. Mars had once been very different. Billions of years earlier, liquid water had flowed across its surface. Rivers had shaped its valleys. Lakes had filled its basins. Perhaps, long ago, Mars had even been habitable. By the early 21st century, robotic explorers were traveling across its deserts. Slowly, carefully, sending images back to Earth. They crossed ancient lake beds, climbed dusty hills, drilled into rocks that had formed billions of years earlier. Every discovery raised a new question. If Mars had once contained water, could it also have supported life? And if life had once existed there, what traces might still remain beneath the red dust? While these questions fascinated scientists, another idea slowly began to grow. Mars was not only a place to study, it might also become a place to live. Among all the worlds of the solar system, Mars was the most similar to Earth. Its day lasted almost the same length, 24 hours and 39 minutes. Its gravity, though weaker, was strong enough that humans might eventually adapt to it. And beneath its surface lay frozen reserves of water ice, the essential ingredient for life. By the early decades of the 21st century, a new question began to emerge. Not whether humans would explore Mars, but whether they might one day settle there. At the same time, something important was happening much closer to Earth. Humans were preparing to return to the Moon. In 2022, the Artemis program launched its first mission. A new era of lunar exploration had begun. The Moon would become humanity's testing ground, the place where engineers would learn how to build habitats, recycle air and water, and survive far from Earth for long periods of time. These lessons would prove essential, because reaching Mars would be far more difficult than reaching the Moon. The Moon lies only 3 days from Earth. Mars lies tens of millions of kilometers away. A rescue mission is possible from the Moon. From Mars, it is not. Anyone traveling to the Red Planet would need to survive on their own. For months, possibly for years. By the 2030s, the idea of a human mission to Mars was no longer science fiction. It had become a technical challenge, a challenge that engineers, scientists, and astronauts were now preparing to solve. But before humans could attempt the most dangerous journey in history, another generation of explorers had to go first. Robots. Machines that would cross the deserts of Mars and prepare the way for humanity's arrival. Chapter 2. The Robotic Pathfinders. Before humans could walk on Mars, machines had to go first. For decades, robotic explorers became humanity's eyes and hands on the red planet. They studied the soil, they searched for water, and they revealed a world far more complex than anyone had imagined. The first successful rover to explore Mars arrived in 1997. It was called Sojourner. Small, slow, and experimental, the rover traveled only a few hundred meters across the Martian surface. Yet its success proved something important. Machines could operate on another planet. In the years that followed, new missions became far more ambitious. In 2004, 2 rovers landed on opposite sides of Mars, Spirit and Opportunity. Originally designed to operate for just 90 days, they continued exploring for years. Opportunity traveled more than 45 kilometers, crossing ancient plains and crater rims. Along the way, the rovers made a remarkable discovery. The rocks they studied had formed in the presence of liquid water. Mars had once been wet. In 2012, a much larger rover arrived. Curiosity. It carried laboratories capable of analyzing the chemistry of Martian rocks in extraordinary detail. Curiosity explored Gale Crater, where scientists believed an ancient lake had once existed. Its findings confirmed what earlier missions had suggested. Billions of years ago, Mars may have been habitable. But exploration did not stop there. In 2021, another rover landed on the red planet, Perseverance. Its mission was different from those before it. Instead of only studying rocks, Perseverance began collecting samples. Small tubes of Martian soil and stone were carefully sealed and stored. One day, these samples would be returned to Earth. Perseverance also carried a small experimental helicopter, Ingenuity. It was the first aircraft ever to fly on another planet. In the thin Martian atmosphere, its tiny rotors spun faster than those of any helicopter on Earth. Against all expectations, it succeeded. Ingenuity proved that aerial exploration on Mars was possible. By the early 2030s, Mars' orbit had become crowded with scientific spacecraft. Orbiters mapped the planet with incredible precision. They measured the depth of valleys, the thickness of the polar ice caps, and the hidden reservoirs of water ice buried beneath the surface. These discoveries changed how scientists viewed Mars. The planet was no longer only a place to study the past. It was becoming a place where humans might survive. One resource mattered more than any other: water. Frozen water existed beneath large areas of the Martian surface. If extracted, it could provide drinking water. It could produce oxygen for breathing. And it could be split into hydrogen and oxygen to create rocket fuel. But the robotic missions were not only searching for resources, they were also preparing landing sites for the future. Engineers needed to know where spacecraft could land safely, where dust storms were less severe, where sunlight was strong enough to power solar systems, and where underground ice was close to the surface. By 2035, several potential landing regions had been carefully mapped. Flat plains near buried ice deposits became the most promising locations. These places could support the first human bases. At the same time, something important was happening much closer to Earth. Humans were learning how to live beyond their home planet. On the Moon, the first permanent habitats had already been established in 2034. Astronauts were testing life support systems that recycled air and water. They were studying how human bodies reacted to living in lower gravity. And they were learning how to survive in an environment that was both hostile and unforgiving. The Moon had become a proving ground. Every lesson learned there would later be used on Mars, because Mars would be far more difficult. The Moon was only 3 days away. Mars was months away. A broken system on the Moon could eventually be repaired from Earth. On Mars, there would be no quick rescue. Every piece of equipment had to work. Every system had to be reliable. Every decision had to be correct. By the late 2030s, robotic missions had answered the most important questions. Where to land, where to find water, and how to survive the planet's dangerous environment. Mars was ready. For the first time in history, humanity possessed the knowledge needed to attempt a human mission to another planet. But knowledge alone was not enough. The journey to Mars would require something even more difficult: a spacecraft capable of carrying Hume. Chapter 3: The Long Preparation. By the late 2020s, the idea of sending humans to Mars was no longer distant speculation. It had become a long-term objective. But before astronauts could attempt the journey to another planet, humanity needed to learn something essential: how to live beyond Earth. The first step in that preparation did not take place on Mars. It happened much closer to home, on the Moon. In 2022, the Artemis program began a new era of lunar exploration. Its goal was not only to return astronauts to the Moon, it was to stay. Throughout the late 2020s, a series of missions gradually rebuilt humanity's presence in deep space. Artemis missions transported crews, equipment, and scientific instruments to the lunar surface. Orbiting above the Moon, a small station known as the Gateway began to take shape. It served as a staging point for missions traveling deeper into the solar system. These missions were more than symbolic. They were experiments. Engineers needed to understand how humans could survive far from Earth for long periods of time. Astronauts tested systems that recycled water and air. They studied how the human body adapted to reduced gravity. And they learned how to maintain complex machinery in an environment where every failure could become fatal. By 2034, the first permanent lunar habitat was established. For the first time, humans were living continuously on another world. Small crews rotated through the base. Some stayed for months. Others remained for more than a year. The moon became a laboratory for survival. Astronauts learned how to extract water from ice buried in permanently shadowed craters. They converted that water into oxygen for breathing and hydrogen for fuel. These technologies would later become essential for Mars missions. At the same time, Earth orbit was undergoing its own transformation. Reusable rockets had dramatically reduced the cost of launching cargo into space. By the mid-2030s, launches from Earth occurred almost every week. Some carried satellites. Others delivered massive structural components for spacecraft that would never enter Earth's atmosphere. Instead of launching complete vehicles from the ground, engineers began assembling them in orbit. Large construction platforms, sometimes called orbital shipyards, floated hundreds of kilometers above Earth. Robotic arms and automated systems connected modules delivered by dozens of launches. Slowly, the first true interplanetary spacecraft took shape. These vehicles were unlike the rockets of the 20th century. They were designed for long journeys. Rotating habitats created artificial gravity for the crew. Radiation shielding protected astronauts from cosmic rays. Large solar arrays provided power during the months-long voyage through deep space. Every part of the mission was carefully studied. How much food would the crew need? How would they deal with medical emergencies? What would happen if a critical system failed halfway between Earth and Mars? There would be no quick rescue, no rapid return. Once the spacecraft departed Earth orbit, the astronauts would be on their own. Another challenge involved timing. Mars and Earth move around the Sun at different speeds. The optimal launch window appears only once every 26 months. If a spacecraft missed that alignment, the mission could be delayed for more than 2 years. Engineers therefore planned every step of the mission years in advance. Cargo landers would travel first. They would deliver habitats, power systems, and supplies to the Martian surface before the astronauts even left Earth. If those systems failed to land safely, the crewed mission would be canceled. By the late 2030s, several uncrewed cargo missions had already been sent to Mars. Automated landers deployed solar arrays. Robotic vehicles began assembling the first small base. Storage tanks were filled with fuel produced from Martian resources. Everything had to be ready before humans arrived. Back on Earth, the first crew for the Mars mission was being selected. Thousands of applicants competed for only a few positions. The chosen astronauts would become the first humans to leave the Earth-Moon system and travel to another planet. Training lasted years. The crew practiced emergency procedures inside underwater habitats. They simulated long periods of isolation. They studied geology, engineering, medicine, and spacecraft operation, and the launch window for the journey to Mars was approaching. Humanity had spent nearly a century preparing for this moment. Now, only one step remained. The first crew would have to leave Earth behind and begin the longest voyage ever attempted by human explorers. Chapter 4: The First Mission. By the early 2040s, everything was ready. The spacecraft had been assembled in Earth orbit. Cargo habitats were waiting on the surface of Mars, and the launch window between the two planets was approaching. For the first time in history, humanity was prepared to attempt a journey to another world. The crew selected for the mission consisted of 6 astronauts. They came from different nations and different scientific disciplines: engineers, geologists, medical specialists. Each of them had spent years preparing for a journey unlike any mission before it. Once they departed Earth orbit, they would travel farther than any humans in history. And for many months, Earth would become only a distant point of light behind them. The spacecraft that would carry them to Mars was not launched from Earth in a single piece. Instead, it had been assembled slowly in orbit. Over the course of many launches, massive modules had been delivered to a construction platform above Earth. Robotic arms connected them together. Power systems were installed. Life support systems were tested again and again. When construction was complete, the vehicle stretched hundreds of meters in length. At its center was a rotating habitat ring. As it slowly spun, the rotation created artificial gravity for the astronauts during the long journey. Around the crew habitat were thick protective layers of water and specialized shielding. These barriers were designed to reduce the effects of cosmic radiation. In deep space, far from Earth's magnetic field, radiation exposure becomes one of the greatest dangers for astronauts. Large solar arrays extended outward like wings. They produced the electricity needed to power life support systems, computers, and communications. At the rear of the spacecraft, powerful engines would guide the vehicle along its months-long trajectory toward Mars. In 2041, the crew finally boarded the spacecraft. One by one, they arrived from Earth aboard reusable orbital transport vehicles. The astronauts entered the habitat that would become their home for the next year. For several weeks, the spacecraft remained in Earth orbit. Engineers on the ground conducted final inspections. Every system was tested: navigation, power generation, air recycling, water recovery. Nothing could be allowed to fail once the journey began. Then the day arrived, the departure burn. At precisely calculated moment, the engines ignited. Slowly at first, the spacecraft began to accelerate. Earth's gravity loosened its hold. The vehicle moved onto a trajectory that would intersect the orbit of Mars. The journey had begun. The distance between Earth and Mars changes constantly as the planets move around the Sun. At their closest, they can be about 55 million kilometers apart. During this mission, the astronauts would travel for nearly 7 months before reaching their destination. As the spacecraft drifted farther from Earth, the blue planet slowly shrank behind them. Within days, Earth was no longer a world filling the sky. It had become a bright sphere, then a small blue star. Life aboard the spacecraft settled into a careful routine. The astronauts exercised daily to maintain their muscles and bones. They performed scientific experiments during the long journey, and they constantly monitored the spacecraft's systems. Outside the windows, deep space remained silent. There were no landscapes, no horizons, only darkness, scattered with distant stars. Psychologically, the journey presented challenges that no human had ever experienced. The crew was traveling farther from Earth than any explorers before them. Communication with mission control grew slower each day. Radio signals required longer and longer to cross the growing distance between the planets. Eventually, the delay reached several minutes. Conversations with Earth were no longer immediate. Every message had to cross millions of kilometers of space. During this time, the astronauts understood something profound. For the first time in human history, a group of people was traveling permanently beyond the immediate reach of Earth. Month after month, the spacecraft moved silently through the darkness between worlds. Slowly, almost imperceptibly, Mars began to grow larger in the windows of the ship. At first, it appeared only as a faint reddish point. But as the weeks passed, the planet expanded into a visible disk. Its deserts and polar caps gradually became recognizable. Humanity was approaching another world, a planet that had fascinated scientists and dreamers for centuries. A world no human had ever seen up close, until now. Chapter 5: Arrival at Mars. After nearly 7 months of travel through deep space, the spacecraft finally approached its destination, Mars. From a distance, the planet appeared small and quiet, a reddish sphere suspended in darkness. But as the spacecraft drew closer, the details of the surface slowly began to emerge. Dust-covered plains, ancient volcanoes rising above the horizon, and vast canyon systems stretching across entire continents. Mars was both familiar and alien. Its deserts resembled landscapes on Earth, yet the colors were deeper, the atmosphere thinner, and the silence more profound. As the spacecraft entered Mars orbit, the crew began preparing for the most dangerous phase of the mission: landing. Landing on Mars is far more difficult than landing on the Moon. The planet's atmosphere is too thin to slow a spacecraft completely using parachutes. But it is thick enough to generate intense heat during atmospheric entry. Engineers sometimes describe this challenge as entering an atmosphere that is both too much and not enough. Too much to ignore, but not enough to rely on. The landing vehicle separated from the main spacecraft and began its descent toward the Martian surface. Inside the cabin, the astronauts monitored dozens of systems simultaneously: navigation, heat shield temperature, descent velocity. Within minutes, the capsule struck the upper layers of the Martian atmosphere. Friction heated the exterior of the vehicle to thousands of degrees. The heat shield glowed as plasma streamed across its surface. The capsule slowed rapidly, but it was still moving far too fast to land safely. At a precisely calculated altitude, a massive supersonic parachute deployed. The canopy expanded violently in the thin air. For a moment, the spacecraft stabilized. Then the parachute separated. Retro rockets ignited beneath the vehicle, firing downward as the capsule approached the landing site. The final descent lasted only seconds. Dust erupted across the surface as the engines slowed the craft. And then, touchdown. The year was 2043. For the first time in human history, humans had landed on another planet. Outside the spacecraft stretched an immense red desert. The horizon appeared slightly closer than on Earth, shaped by the planet's smaller size. The sky above them glowed with a soft, dusty orange. The mission had succeeded. Finally, the hatch opened. One astronaut slowly descended the ladder toward the surface. The Martian soil lay undisturbed beneath their boots. When the astronauts stepped onto the ground, humanity reached a new milestone. For the first time in history, human footprints marked the surface of another world. The gravity felt different. Mars possesses only about 38% of Earth's gravity. Movements were lighter. Steps carried farther. Even simple motions required adjustment. Nearby, robotic cargo landers stood where they had arrived months earlier. Solar arrays were already producing power. Pressurized habitat modules waited to be activated. The first base on Mars had been prepared in advance. The astronauts began unloading equipment from the landing vehicle. Scientific instruments, surface vehicles, communication systems. Every piece of equipment had been carefully designed for this moment. For hours, the crew worked across the landing site, setting up antennas, deploying sensors, and connecting the first habitat to its power supply. Above them, the Sun appeared slightly smaller than it does from Earth. Mars orbits farther from the Sun, receiving less light and warmth. Even during the day, the temperature remained far below freezing. Yet despite the cold and the silence, the significance of the moment was unmistakable. Humanity had crossed the vast distance between planets. The red world that had once existed only in telescopes and imagination was now beneath their feet. But the day was not yet over. Soon, the sun would set behind the Martian horizon. And with that sunset would come a realization none of the astronauts had fully experienced before. For the first time in their lives, they would spend the night on another planet. Chapter 6: The First Martian Night. After many hours of work, the first base on Mars was finally operational. Power systems were connected, communication antennas were aligned with Earth, and the habitat modules were pressurized and ready for the crew. Outside, the Martian day was slowly coming to an end. The sun moved lower in the dusty sky. Its light appeared softer than on Earth, filtered through the thin atmosphere of the planet. Mars rotates slightly more slowly than Earth. A full Martian day, called a sol, lasts 24 hours and 39 minutes. This small difference would eventually shape the rhythm of life for every future settlement on the planet. But on that first day, the crew was still adjusting to everything. As the sun approached the horizon, the long shadows of rocks and equipment stretched across the landing site. The temperature began to fall quickly. On Mars, heat escapes easily into space, and when darkness arrives, the cold becomes intense. The astronauts stepped outside the habitat one final time before nightfall. For a moment, they simply stood in silence, looking across the landscape. The Martian desert stretched endlessly in every direction. No vegetation, no water, no sound of wind or animals. Only dust, rock, and the faint whisper of the planet's thin atmosphere. Slowly, the sun disappeared below the horizon. The sky shifted from orange to deep violet, and then to black. One by one, the stars began to appear. Without a dense atmosphere to scatter light, the night sky above Mars looked extraordinarily clear. Thousands of stars filled the darkness, more than most humans had ever seen from Earth. Among them, one point of light held special meaning. Low above the horizon, a small blue star shone quietly. It was Earth. From Mars, Earth appears no larger than a bright planet in the night sky. The world that had given birth to humanity was now only a distant point of light. For the astronauts standing on the Martian surface, that realization carried enormous weight. Every human who had ever lived had been born on Earth. Every civilization in history had existed on that single world. And now, for the first time, humans were living somewhere else. Communication signals between Mars and Earth required time to travel. Depending on the distance between the planets, radio messages could take up to 20 minutes to arrive. Conversations with mission control were no longer immediate. Mars was no longer part of Earth's immediate environment. It was another world. Inside the habitat, the crew began their first night on the planet. They reviewed data from the landing, checked environmental systems, and prepared for the work that would begin the following day. In the years ahead, more missions would follow. New crews would arrive. The small research outpost would slowly expand into a permanent settlement. Eventually, entire cities would grow beneath protective domes and underground habitats. Mars would become humanity's second world. But on that first night in 2043, none of that future was certain. All that existed was a small base in an immense desert, 6 astronauts, and a distant blue star rising slowly above the Martian horizon. I am Aurora. This record is complete. Chapter 7: The Beginning of a New World. When the first humans landed on Mars in 2043, their mission was planned to last only a limited time. The base they activated had been designed as a research station, a temporary outpost, a place to study the planet and prepare for future missions. But history rarely follows the limits of its first plans. Once humanity had successfully reached Mars, a new question began to emerge. Not whether humans could visit the red planet, but whether they could remain there. In the months following the first landing, the astronauts conducted dozens of scientific experiments. They studied the geology of the surrounding region. They drilled into the Martian soil, and they confirmed the presence of frozen water beneath the surface. This discovery was critical. Water meant survival. It could be purified for drinking, converted into oxygen for breathing, and separated into hydrogen and oxygen to produce rocket fuel. The small base established in 2043 had been supplied by cargo missions launched years earlier. But long-term survival on Mars would require something different. Local resources. The ability to produce air, water, and fuel directly on the planet itself. Engineers on Earth had already begun developing these technologies. Systems capable of extracting water from underground ice. Machines that could convert the carbon dioxide in the Martian atmosphere into oxygen. And reactors that could produce methane fuel for spacecraft returning to orbit. Meanwhile, the success of the first mission changed how humanity viewed Mars. For decades, the planet had been a distant scientific objective. Now it had become a reachable destination. On Earth, interest in Mars grew rapidly. Governments expanded their space programs. Private companies began planning commercial missions. And new generations of engineers started designing spacecraft capable of carrying larger crews. At the same time, activity on the Moon continued to expand. The permanent lunar habitats established in 2034 were growing into small settlements. Water extraction from polar ice supported longer missions, and lunar launch facilities began sending cargo toward Mars. The Moon had become humanity's gateway to the deeper solar system. Mars was the next step. By the late 2040s, additional missions were already being planned. New cargo landers would deliver larger habitat modules. Surface vehicles would expand exploration beyond the first landing site, and the small research base would slowly transform into a permanent outpost. For the astronauts of the first mission, however, the most important achievement had already been accomplished. They had proven that humans could travel between planets. They had demonstrated that life on Mars was possible. The red planet was no longer a distant symbol in the night sky. It had become part of humanity's living geography. Another world where human footprints existed. In the decades that followed, those first footprints would multiply. Research stations would grow into settlements. Settlements would become cities. And Mars would eventually develop its own culture, its own history, and its own generations born beneath its pale sky. But all of that future began with a single mission, a small base in an empty desert, and 6 explorers who crossed the vast distance between worlds. Their arrival marked the beginning of a new chapter in human history, the moment when humanity ceased to belong to only one planet. I am Aurora. This record is complete.